Today's lesson is Unit 2, Lesson 8, Equations with Variables on Both Sides. We will learn how to solve equations that have variables on both sides of the equation, and we'll also talk about recognizing identities and problems with no solution. The first thing that we need to do when we solve equations with variables on both sides is to simplify each side if need be. So if we have to combine like terms or if we have to distribute, we need to do that before we get started. In our first two examples, both sides are already simplified, so we're not going to need to do that. So what we're going to do is move the variables to one side and the numbers to the other. So I want to have all of my x's on the left-hand side and all of my non-x's, or all of my numbers, on the right-hand side. And I do that the same way that I did to get rid of numbers that were in the way when we were trying to isolate the variable. So if I want this 2x to be on the same side as the 5x, I'm just going to subtract it from both sides. So minus 2x minus 2x. On the right side, when I do 2x minus 2x, I have no more 2x. That's 0. So I've gotten rid of it. I've moved it to the left side. 5x minus 2x is 3x. I still have my plus 2. I can't combine that because it's not a like term. And on the right side, I have 14. Now I have a simple two-step equation. Subtracting 2 from both sides gives me 3x equals 12. Dividing both sides by 3 gives me x equals 4. Now I'm going to check to make sure my answer is correct by substituting it back into the original equation. So I'm going to take my original equation, and every place where I have an x, I'm going to put a 4 instead. So this is 5 times 4 plus 2, and that should be equal to 2 times 4 plus 14. 5 times 4 is 20. 20 plus 2 is 22. And on the other side, 2 times 4 is 8, and 8 plus 14 is 22. So I can be sure that I solved correctly for x. Okay, let's take a look at the second example. We have 7k plus 2 equals 4k minus 10. The first thing I'm going to do is put all of my variables on the left-hand side. Now, it doesn't matter whether they're on the left or the right. You could move all the variables to the right, and there are some cases where it's more convenient to do that, but for this case, we're just going to move 4k to the left. We're going to do that by subtracting it from both sides. So minus 4k minus 4k. 7k minus 4k is 3k plus 2 equals negative 10. The 4k is gone from this side because 4k minus 4k is 0. Now I have a two-step equation. Subtracting 2 from both sides gives me 3k equals negative 12. Dividing both sides by 3 gives me k equals negative 4. And I'm going to check that. So here's my check. 7 times negative 4 plus 2 should equal 4 times negative 4 minus 10. 7 times negative 4 is negative 28. Negative 28 plus 2 is negative 26. 4 times negative 4 is negative 16, and negative 16 minus 10 is negative 26. Okay, let's look at some additional examples. For these examples, we are going to have to simplify by distributing before we can move variables to one side or the other. So I'm going to distribute my 2 to the 5x and the negative 1. 2 times 5x is 10x. 2 times negative 1 is negative 2. Doing the same thing to the other side, I have 3x plus 33. Now I'm going to move my variables to the other side. So I'm going to subtract 3x from both sides. 10x minus 3x is 7x. I still have minus 2. Still have equals. 3x minus 3x is 0, so I'm not going to write anything there. And then I have positive 33. Now it's a two-step equation. Adding 2 to both sides gives me 7x equals 35. Dividing both sides by 7 gives me x equals 5. And again, I can check my work. 2 times the quantity 5 times 5 minus 1 should be equal to 3 times the quantity 5 plus 11. 5 times 5 is 25. 25 minus 1 is 24, so I have 2 times 24 should be equal to 3 times 16. 2 times 24 is 48. 3 times 16 is also 48, so my answer is correct. Okay, next example. We have 8y plus 4, and again I'm distributing, is equal to 2y. 2 times negative 13 is negative 26. I'm going to move all of my variables to the left-hand side, so I'm going to subtract 2y from both sides. 8y minus 2y is 6y. 2y minus 2y is 0, so I'm just left with negative 26 on the right side. Now I have a two-step equation. Subtracting 4 from both sides gives me 6y equals negative 30. Dividing both sides by 6 gives me y equals negative 5. And I'm going to check my work. 4 times the quantity 2 times negative 5 plus 1 should equal 2 times negative 5 minus 13. 2 times negative 5 is negative 10, plus 1 is negative 9. And that should be equal to 2 times negative 5 minus 13 is negative 18. 4 times negative 9 is negative 36, and 2 times 18 is also negative 36. Okay, last example. This one, my distributing is a little bit different over here. I just have a negative sign in front of the parentheses. So I'm going to just be distributing the negative sign. I could imagine this as being negative 1 times a minus 4. That's what that really means. So if you want to write a 1 in there, that may help you as well. 7 times 4 is 28 minus 7a. I'm going to distribute my negative sign. So negative 1 times a is just negative a. And negative 1 times negative 4 is positive 4. So when you distribute a negative sign, you are just changing signs.
Regula and Jackson Rand, please report to the office. Bailey Regula, Jackson Rand, please report to the office.
You're just changing the signs of everything that is within the parentheses. Okay, now, again, I'm going to move my variables to the left side. If you wanted to, you could add 7a to both sides and you'd have your variables on the right. Just to keep it consistent, I usually always move them to the left, but this is a case where if you added 7a to both sides, you would have a positive number over here, so some of you might like to avoid dealing with that negative, and you could do it that way. So to get rid of a negative a, I have to add a to both sides. So I have 28, negative 7 plus 1 is negative 6, so I have negative 6a equals 4. Now it's a two-step. Subtracting 28 from both sides gives me negative 6a equals negative 24. Dividing both sides by negative 6 gives me a equals positive 4. Now I'm going to check my work. 7, whoops, hang on, let me get rid of that parenthesis that shouldn't be there. Okay, 7 times 4 minus 4 should equal a negative 4 minus 4. On this side I have 7 times 4 minus 4 is 0 equals negative 4 minus 4 is 0. And 7 times 0 is 0, and a negative 0 is still 0. So that one checked out just fine. Okay, next thing that we need to talk about are identities and equations with no solution. An identity is true for any value of x. So for this equation, no matter what I put in for x, both sides are going to be equal. And I'll show you how you can recognize identities. So if I were to simplify this equation, I have 10x plus 12 equals, I'm going to distribute, so I have 10x plus 12. Now you can already see both sides are the same. There's an equivalent expression on each side, so no matter what I put in for x, it's going to be the same. If I wanted to continue solving this, I could subtract 10x from both sides. I have no x's on this side, I just have 12. And on this side I have no x's, I just have 12. So no matter what I put in for x, 12 is always going to equal 12. So this is true for any value of x. So if your x's eliminate from both sides, you're left with a statement that is true, such as 12 equals 12. Then you know you have an identity that would be true for any value of x. Let's look at what happens if you have an equation with no solution. If an equation has no solution, it's never true. There's nothing you can put in for x that will make it true. So first I'm going to simplify both sides. I have 9m minus 4. I'm going to combine my like terms. Negative 3m plus 12m is 9m plus 5. Now you may already be able to see that there's nothing you could put in for 9m because this side is subtracting 4 and this side is subtracting 5. But let's continue to try to move our variables. If I subtract 9m from both sides, I don't have any more variables. And I have a statement that says negative 4 is equal to 5. Well, that is not true. Negative 4 does not equal 5, so this equation has no solution and it is never true. Okay, we're now going to look at some examples of some word problems. Most likely in class we will only do half of this within a class period, so you can probably stop the video here and work on your homework, and then the next class period you can watch the other half of this video. Okay, so here's how we use an equation with variables on both sides in a word problem. It's an example from graphic design, and this is from your textbook. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So to solve a problem like this, we are going to write an expression for one scenario and then make it equal to the expression for the other scenario. First, I'm going to define my variable. It says how many web pages would the designer have to make. So I'm going to say that W is the number of web pages that would have to be created. The first scenario is that it takes a graphic designer 1.5 hours to make one page. So for every page, the designer has to spend 1.5 hours. So we have 1.5 times the number of pages is going to be the total length of time it would take a designer to make the website.
Just a reminder to varsity football players, report to Mr. Munster's room when the bell rings. Again, varsity football players, report to Mr. Munster's room when the bell rings. Thank you.
Okay. The other scenario is that the designer could complete each page in 1.25 hours, so that's less time, but it takes 8 hours to learn the software.
Isaac Hutchinson, Kimmy Harper.
Okay, so for this side we have, it's going to take 1.25 hours for every web page, so we're going to multiply that times the number of web pages, plus it's going to take 8 hours to learn the software. Okay, now we can solve this. I'm going to move my variables to one side, so I'm going to subtract 1.25w. And on this side, if I have a half and I take away a fourth, I'm left with a fourth, which is 0.25w equals 8. Dividing both sides by 0.25. If I divide 8 by 0.25, w is going to equal 32. So the designer would have to make 32 web pages in order to save time using the new software. So actually, when the designer makes 32 web pages, it would be exactly the same amount of time to create the website. So once we go beyond 32 pages, then the designer is going to be saving time. Okay, next example is one for you to try. So pause the video, give this a try, and then come back to check in. Okay, so first we have the electric monthly bill is going to be reduced from $112 to $88 a month. So that's a nice savings. It's going to cost $88 a month instead of $112 a month, but they have to spend some more money to get the energy saving copier. So it asks, in how many months will the copier pay for itself? We're going to let M equal the number. You guys may know that as a hashtag, but it really means number of months. So the first scenario, the monthly bill is $112 times the number of months. The second scenario, it's only $88 times the number of month, but we have to add the $650 for buying the copier. So now solving this equation will let us know how many months it will take until we break even. I'm going to get the variables on one side, so I'm going to subtract 88M, and I get 24M equals 650. Okay, now dividing both sides by 24 gives me that M would equal 27.083 repeating. So after 27 months, it still hasn't paid for itself because it's slightly over 27 months. So sometime after that 27 months, the copier will have paid for itself. So since it's asking us how many months, we could say that in, we could actually say this amount, but we would say in the 28th month, the copier will have been paid for, and we would be starting to see the benefit from spending the extra money on the copier in the first place. Okay, your assignment, if you're in regular Algebra 1 class, your assignment is page 105, 11 through 31 odd, and also number 42. If you are in honors algebra, your assignment is the challenge assignment. Thank you for watching.